Hi, my name is Shivani, and this is my lab report for constant velocity. Part 1, Introduction. In this lab, our purpose is to observe the motion of some object that is moving at the same speed without changing direction. Compare the motion through observational analysis and a computational model. The results obtained in this experiment showed that there was a correlation between the observational analysis and the computational model. However, the correlation was weak. Part 2, Background information. In this lab, we are exploring the concepts behind Newton's second law. Above in red is one of the formulas that Newton's second law represents. Essentially, it states two things. A force is a result of a change in mass or velocity, and that a change in velocity of an object occurs with a presence of a net force. In this experiment, the goal is to keep an object at constant velocity. To do so, the system must have no net forces acting upon it. Part 3, Observational Data Using Tracker. In this part of the experiment, I take a video of an object rolling and using tracker, plot the distance versus time to determine the velocity of the object. For my observational data, I chose to roll a glue stick on a flat table. The center of mass of the object was the middle of the glue stick, and it rolled down the table, the x-axis. Here is the data regarding time and position collected from the video using tracker. The time is shown in the first column and the x-axis of the chart. The interval used for time was 0.033 seconds. The position in meters is shown in the second column and on the y-axis. To calculate the initial velocity of the object, the formula velocity equals to change in position over change in time was used. In this case, the initial position 3.58 times 10 to the negative third was subtracted from the final position of 8.71 times 10 to the negative third, and then divided by the interval of time, 0.033 seconds. The constant velocity determined was 0.1552 meters per second in the positive x direction. Part 4, Modeling Data Using GlowScript. In this part of the lab, the data collected from the observational data in the last slide is used in coding a model of an object moving at that constant velocity calculated. In the GlowScript code, the formula highlighted in red represents Newton's second law and how it's used to calculate final velocity. The blue represents the position formula, calculating the final position of the object. In the code, the mass of the object in kilograms was 0.0153. The position vector was changed to 0.003485 meters, which was the initial position of the object on the x-axis of the tracker. The velocity vector was 0.1552 meters per second, which was calculated from the observational data. The starting time was 0.039 seconds. Delta t is changed to 0.033, which just represents the interval of time. And the video was only collected for 0.673 seconds, thus the t is less than that time. This is the graph that is the model of the observational data and how the observational data should look like if the velocity was actually constant throughout the entire experiment. Part 5, Data and Results. In this next part, the two sets of data are compared. The data shows that the two don't match up perfectly. The model shows the change in position if it were perfectly constant velocity. The observational shows that the glue stick is slowing down and not keeping at constant velocity. In conclusion, there were net forces acting on the glue stick, causing it to not have constant velocity. Discussion question. What if when you analyze your video data in tracker, you made a choice of orientation of axis? Discuss briefly how your results would change and how they would remain the same if you were to flip the axis. Well, if you flip the axis, the movement of the ball would be in the positive y direction as opposed to the positive x direction. The numbers calculated in the velocity vectors would not change, but instead of there being zeros at the y and z component, there would be zeros at the x and z component. Your observations can be predicted well by a computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls are added together to give the net force in case in the case that you observed, discussed briefly. These are all the forces acting on the glue stick. The forces in the y direction include gravity and the table, and because they cancel it, these pushes and pulls make it so the object does not move in the y direction at all. On the other hand, there's a force in the negative x direction that will cause the glue stick to slow down over time, and that opposing force is friction. End of presentation.